Howdy kids, and welcome to our review over similar figures. The first thing that you need to remember is corresponding sides are in fact proportional. Also, corresponding angles are congruent. Let's look at number 1. Observe the graph of the 3 similar triangles below. Record the ratios of the lengths of the bases and heights for each of the similar triangles in the tables below. Okay, the first thing that it tells us to do is look at the base and the height, and we're looking at triangle ABC. That is the smaller triangle that you see on the graph. The base measures 3. That is the numerator. The height is 4, so that is your denominator. Okay, now we're going to look at triangles D, B, and E. D, B, E. What is the measure of the base? Looks like it measures 6. And the height is 8. Okay, now we'll look at the largest triangle. It measures 9 as the base and 12 as the height. You see that triangle in green. Okay, and that was 9/12. Now, if you will take each of those fractions and simplify them, our common ratio is 3/4. Okay, let's continue with height divided by base. That is in the next table. We have the height of ABC measures 4 and the base is 3. The height of the middle triangle is 8 and the base is 6. And when we look at triangle FBG, our height is 12 and the base is 9. If we take all of those fractions and simplify them, our common ratio is 4/3. Okay, what do you notice about the ratio of the base and height? The answer to this is that the ratios are equivalent ratios. When simplified, the ratios are equivalent to 3/4. Okay, going on to part C. Okay, what do you notice about the ratios of height to base? Okay, the ratios here are also equivalent, and they are equivalent to 4/3 when they are simplified. Okay, D. What is the relationship between the ratio of base to height and height to base? And we're going to introduce a new term. These are reciprocals of each other. Whenever you can take a fraction and flip it over, it is a reciprocal. So the ratio of base to height is 3/4, while the ratio of height to base is 4/3. These are also called inverses because if you multiply them, you get 1. If we multiply 3/4 times 4/3, we would get 1. Therefore, it is an inverse. Okay, letter E. What do you know about the lengths of the corresponding sides of these triangles? And we know that all of the corresponding sides are proportional. Alright, let's look at the table. I have gone ahead and filled in the measurements of the angles. I know that you guys know how to do that. You learned that in 6th and 7th grade. So looking at triangle ABC, the measurement of angle CAB is 37. The measurement of ABC is 90, and the measure of BCA is 53 degrees. When we look at that, we have 3 different measurements, and one of them measures 90 degrees. That gives us a right triangle, but because all of the dimensions are different, all of the angles are different measurements, that gives us a right scaling triangle. So on letter A, your answer is going to be each triangle is a right scaling triangle. Okay, going on to question B. What do you notice about the corresponding angles of each triangle? When we look at this, we notice that angle CAB, angle DEB, and angle GFB are all the same. When you go down the middle, you have a 90-degree angle on all of those. And on the right-hand side, you have a 53-degree angle on all of those. So we can answer that as corresponding angles are congruent. Alright guys, you have 2 more pages that go along with this sizing up figure summary. You need to do page 3 and page 4 on your own.
Okay, now we're going to do some translations, reflections, and dilations. Before we begin, though, I want to definitely give a shout out to a student in my first period class that texted me about the video and came in early and watched the video. So way to go, Ruben. Okay, so let's look at a reflection first. On A, we're going to do A together, and it says that we are going to reflect the original figure across the x-axis. So first we need to graph the points of the original figure. So we need to graph 4, 3, so that means we go over 4 and up 3, and that's going to be A. And then we're going to go over 2 and up 3, and that will be our B. Then we're going to go over 1 and up 1 for C, and over 5 and up 1 for D. And if you look at this shape, it looks like a trapezoid to me. So now we have to figure out the coordinates for the new shape if we reflect it over the x-axis. So I want to highlight the x-axis so we know what we're going to reflect over, because I know sometimes you get confused which one's the x and which is the y. So the x-axis is horizontal, so I'm going to reflect over that axis. And what that means is that if I fold my paper right there, my 2 shapes should match up. So I should, I'm going to look for my first point up there, the A, 4, 3, and I'm going to make sure that it is still, the x is still going to be 4, but instead of going up 3, I should go down 3 from the x-axis. And then on my point B, I'm still going to go over 2, but I'm going to go down 3. And then for C, I'm still going to go over 1, but and instead of going up 1, I will go down 1. And then for D, I would still go over 5, but I would go down 1. Now if I draw that trapezoid, it should look like a reflection. So if you fold it over the x-axis, they should match up. So let's label our points, the new points that we did. And if you notice, our x numbers did not change. The only number that changed was the y numbers, and they became the opposite. Because we were reflecting over the x-axis, our y numbers were changing and becoming the opposite. And our 1, -1, and then 5, -1. Now that's how you would reflect an object over the x-axis. Now when you do B and C, make sure that you highlight the axis that they want you to reflect over so you don't get it confused. And B is going to be the y-axis this time. Alright, so let's go look at lation, which is a slide. So we're going to slide a figure. Looks like we're going to make a triangle this time. So let's look at our triangle. We're going to graph our points. We'll go over 2 and up 5 for point P. Then we'll go over 5 and up 1 for point Q. And over 2 and up 1 for point R. It looks like we have a right triangle, which is going to make it even easier. So if you notice, those points are my vertex, or my vertices. So that those are the things that I'm going to move when I translate. And it asks me to translate this triangle 2 units up and 2 units to the right. So I'm going to pick one of my vertices and I'm going to move it over 2 units to the right and then 2 units up and plot my new point. And then I take another vertice and do the same thing. And then my third one, and I go over 2 and up 2. Now my new right triangle, I have translated it. I have slid it over 2 and up 2. Now let's figure out our new points. So if I did change my X and my Y points on this triangle. So if I moved up 2, that means it was positive, a plus. And if I moved right 2, that's also a positive and a plus. So point P was 2, so if I add 2, it becomes 4. And 5, the Y coordinate was 5, so I add 2 and I get 7. So let's add 2 to 5 on the Q, and that makes 7. And add 2 to the 1, and that makes 3. And then add 2 to the R one, and that would be 4 and 3. And if you don't think these are right, just check your points with the new triangle that you graph to make sure that they correspond. Now, make sure that if you go down or if you go to the left, you're going to be subtracting. And pay attention to what they tell you to do on B and C. Now we're going to do a dilation. Dilations, remember, means that they get bigger or smaller by using a scale factor. And a scale factor is what you multiply by. So I'm going to graph my figure first. So my A is 0, 3. My B is negative 2. So it's to the left 2 and up 3. And C is also negative 2. So it's to the left 2, up 1. And D is over 1, up 1. So it looks like we have another trapezoid. And if I'm going to dilate this by a scale factor of 2, the easiest thing to do is look at your points, and you have to multiply your X by 2 and your Y by 2. So let's look at point A. If I multiply 0 times 2, I'm still going to get 0. If I multiply my Y number, 3, by 2, I get 6. Then let's look at point B. Negative 2 times 2 is negative 4. And 3 times 2 is 6. And then our point C, negative 2 times 2 is negative 4 again. And 1 times 2 is 2. And on D, 1 times 2 is 2. And 1 times 2 is 2. Now we can plot these points and see our dilation. So our first point is going to be 0, 6. So we go across 0 and up 6. Our second point is going to be to the left 4 and up 6. Our next point will be to the left 4 and up 2. And our last point is going to be over to the right 2 and up 2. And here is our new trapezoid that has been dilated by a scale factor of 2. So make sure that you remember the scale factors, what you multiply by. So if you're multiplying by a number smaller than 1, you're going to get a smaller figure. If you're multiplying by a number bigger than 1, you're going to get a bigger figure as your second one. So make sure you pay attention to that and always use your multiplication. Now you're going to do B and C on your own, and tonight you will also have a video homework to watch at home instead of in class. So I hope that you get that done.